Okay, now we're going to do this third question, and it says, and we're given the K equilibrium constant of 1.2 times 10 to the negative 4. Here's our balanced reaction. Initially, we have 0.1 moles per liter of nitrogen and 0.1 moles per liter of oxygen. They're allowed to reach equilibrium. Determine the concentration of nitrogen monoxide at equilibrium. So let's get to work. First step is, as always, when we're stating the ice table, we want to state the balanced reaction which was given. So it's going to be our nitrogen plus oxygen, which gives us 2 moles of nitrogen monoxide. And I'm going to write the ice for initial change at equilibrium right here. And at initial concentration of nitrogen was 0.100. Initial concentration of oxygen 0.100. Initial concentration of nitrogen monoxide we don't know. So we know that since we added initially the reactants will decrease in concentration, and the products will increase in concentration by the factor of that coefficient. So at equilibrium, we have 2x for nitrogen monoxide and 0.100 minus x and 0.100 minus x for nitrogen and oxygen. And we're going to write it in the form of the K equilibrium expression. So K equilibrium was 1.2 times 10 to the negative 4, which is equal to the products, which is 2x squared over 0.100 minus x squared. However, since we have that minus x, we still have to carry out the approximation to determine whether that value of x is significant or insignificant. So let's plug that in. So initial concentration, which is 0.100 divided by 1.2 times 10 to the negative 4 is equal to, and we'll plug that into the calculator. So 0.1 divided by 1.2 for negative gives us 833. And obviously that's not greater than 1,000, so we'll use that. So which means that x is still significant, so it's going to be, so what I'm going to do is I'm going to root both sides. And let's see what values we get. I didn't do my calculation beforehand, so I'm going to have to do it right now. So bear with me. So 1.2 for negative, the root of that value is going to be 0.10109 is equal to 2x over 0.100 minus x. And multiply that out, so it's going to be 0.0109 times by 0.100 minus x is equal to 2x. Let's multiply that out again, so that's going to be 0.9 times by 0.1, which gives us 0.00109 minus 0.0109x is equal to 2x. I'm going to carry that to the right side. So I'll do it here, up here. 0.0109 is equal to 2.0109x. I'm going to divide that by 2.0109. 2.0109. Let's get our calculator out again. So it'll be 0.109. 0.0109 divided by 2.0. Whoops, no, I did that wrong again. Forgot to put a 0 right here. So here's my calculator, which is 0.00. Oops, make sure I clear everything. 0.00109 divided by 2.0109 gives us 0.00054 2. Well, let's double check. Yeah, so X is equal to 542. And in order to determine the concentration for nitrogen monoxide, it's going to be 2x. So we're going to multiply 2 times the value of our x, which is 0.000542. And since we have that in our calculator already, we'll multiply that by 2, which gives us 0.108. 0.108, which is 1.08 times 10 to the negative 3 moles over liters for nitrogen monoxide. And we're a little bit one off because I think I rounded off a little bit too soon. I should have just kept, when you do this on the calculator, never round it off till the final answer.